Hey everyone! Today we're going to see how to measure the shear modulus of a brass rod in a hands-on, practical way. Forget complicated formulas. We'll just twist the rod, add some weights, and see how it reacts. Let's dive in. In the video titled, How to Measure the Moment of Inertia of a Physical Pendulum, plus Rare Torsion Pendulum Method Explained, we measured it for a wire using time measurements of a torsion pendulum. Now we will measure it more directly for a brass rod, using the torque applied to the rod and the resulting angle of twist of the rod. All we need to do experimentally is twist the brass rod in a direction perpendicular to its axis of symmetry with weights and measure the corresponding angle of twist of the rod. Let's start with the necessary equations. This equation defines the torsional constant, kappa, as the constant of proportionality between the torque, tau, due to the effective gravitational force, mg effective, and the angle of twist, theta. This torsional constant, kappa, depends on the shear modulus, g, according to the following relation which we already introduced in the video How to Measure the Moment of Inertia of a Physical Pendulum plus Rare Torsion Pendulum Method Explained. In this relation, d is the diameter of the circular cross-section of the rod, and L is the length of the rod. Therefore, the shear modulus g can be calculated from the measured torsional constant, kappa, using this relation. How do we determine the torsional constant, kappa? We construct a graph of the torque, tau, due to the effective gravitational force versus the angle, theta, of twist. For example, we can do this for 8 different weights, m, ranging from 0 kilograms to 3.5 kilograms. The angle of twist is plotted in radians. We then fit a straight line to this graph, and its slope gives an estimate of the torsional constant, kappa. We need to measure the diameter of the rod using a micrometer and the length of the rod using a metric ruler. We measure the lever arm of the effective gravitational force using a vernier caliper as the difference between half of the outer diameter of the pulley and the depth of the pulley groove. If you don't know how to use a micrometer or a vernier caliper, watch my videos titled How to Read a Micrometer, 0.01 millimeter precision, explained in 58 seconds, and How to Read a Vernier Caliper, 0.02 millimeter accuracy explained. The angle of twist of the rod, theta, is the same as the angle of rotation of the pulley because the pulley is rigidly connected to the rod's cross-section. Therefore, it can be read directly from the scale on the pulley. And that's how we can determine the torsional constant and the shear modulus of a brass rod from simple measurements. Now you know how force, torque, and material properties all come together, and you can try it yourself. If you found this video helpful, don't forget to like it and subscribe to our channel. Your support enables me to produce more high-quality content. Thanks for watching, and I'll see you in the next video.